Okay, we're going to start off by showing probably our best unit. This was made by my brother, Paul, and you notice it got the same kind of tubing. This is clear. At the time we were using clear. It's still got a hole in it, and then we built these really special hinges here, so we'd have more control, and then you also have a cover. And rather than the model I'm going to show you that we're going into production with to save the expense of the hinges and the special cover, which are really going to be later on down the line. But the important thing is the hole in the lid. And the hole in the lid is here. And what we really have to show you is the technique by which we put the hole in the lid. It's a standard drill, and on it is a standard drill bit. The drill bit is for putting fixtures and ceilings, and it's 6-inch. We like the 6-inch hole because there is a little work that needs to be done inside the bellows after it's to connect it, because you really want to work inside the bellows rather than outside, because you want the outside to have nice, clean, and no edges, and you want all the real work to take place inside, so the outside, the work is invisible, and the 6-inch hole makes that possible. So we've been using the 6-inch hole for that reason. Outside to have nice, clean, and no edges, and you want all the real work to take place inside, so the outside, the work is invisible, and the 6-inch hole makes that possible. So we've been using the 6-inch hole for that reason. We got a toilet that we're working on here. The thing about this is it's a big seat toilet, and the big seats so it's kind of special. We got them, so we got the hole drilled. So we'll show you still photographs of the hole being drilled. And what we have to do is we have to, we've got this one here already made, and this just has to be installed on top. And then the unit's going to finally look like that. And it's good that it's orange because you see it better. And look, it's going to be so solid that you can actually sit on it. And sitting on it's good. Actually squeezes the gaskets together. And then when you're ready to use it, you just pump it like that and she'll flush. And so we also we've been using this neoprene here. And we have to put the neoprene around to make a gasket, so this will be airtight. And then we have to do the same with the one on the top. So those two are airtight. A little tedious. That has to be done, so that's airtight. And then this finally goes on, and you're ready for the air flush. Oh, stop. So once this, okay. So obviously the crucial part of making the device is the air pump that does the work. We've been getting this. This is it's flexible duct, and it's made in North Carolina, which is 10-inch. Now it's not as easy as it seems here, because you want to cut out pieces of flexible duct. Now it comes in these little ribs. Rib is about 2 inches, so we got 1 rib, 2 ribs, 3 ribs, 4 ribs, 5 ribs, 6 max, between 5 and 6 ribs. So you don't really have to measure it, which is really lifesaver, because all you got to do is count ribs. So what I basically do is I put it on 10-inch, it's a little less than 10, got lucky, pot, and I just count out 1 rib, 2 ribs, 3 ribs, 4 ribs, 5 ribs, and then there's that 6th rib, which is the one where the cut's going to go. Now, the interesting thing about cutting it is that when you start at 1 rib, when you start at the middle, the other side comes to the middle. One going up and the other one going down. And it's kind of tricky, and I think I'm going to have to make a cartoon to show how to do this. But so you cut it here and go up and go to the center at 180 degrees. And then you would go down to this one, and that way you'd have a straight cut. And this is a little on the complicated side, so I'm going to have to make a cartoon to do this, or at least a picture illustrating to show you that because the ribs are on an angle, when you cut across, you definitely don't want to stay between ribs because you'll go into a spiral. You want to cut across the ribs, so you start at a rib and then the other side is in between. And then you can see that here, where here's the cut that is the rib. Right there is the cut that is the rib, and then 180 degrees away from it is the half and half. So the cut is different than the spiral. The spiral will get you into like wasting a lot of material. Okay. Now, as we were saying, the perfectly straight cut. See, she's a decent cut, straight. It's not on an angle. Like, see the ribs are going up on an angle? Well, you see the cut isn't going up on an angle. You want that cut straight. Therefore, the rib is cut here and only half here. That's the important thing. Now, every once in a while, you might have a little problem with damage, but don't get upset because look where the tape is going to go. So I have a little damage here, which I fixed with tape. And now we have to talk about tape. Tape is made by a company, and once in a while it gets bad tape. Now, it doesn't throw away its bad tape, meaning that it still could be called tape, but it could be called tape, but we don't want it. And so you really got to pay the piper on this. The best place to buy the tape would be from the guy, the most expensive guy, meaning the people that are installing this stuff. Where you bought this, buy the tape from them. Even though when you look at it, you go, wow, this is more expensive than other places. Well, they're buying the best tape because they're doing the work. The other places will sell tape that is outdated or didn't pass quality control stickum. And so you must have noticed when you get a tape and every once in a while, that's a pretty good roll of tape, this one, you know? But then sometimes I'll show you one over there. It could be the same brand, and it's not very sticky, and we really want sticky. So the job is going to be to put the tape, and it's just, this is the wonderful part about the job. The tape really extends the bellows, and anything that extends the bellows is good because the bellows is the money item, and therefore we're using every available inch of the bellows, because when we finally put the bellows on the seat, the tape is actually going to go there, and the tape is going to go all the way around, and that's why we left the big hole in here so we could put our hand in there and actually put the tape on and do it. This one's been done in reverse, but reverse is going to happen when you're doing on-the-job scene. If you're making them in the factory, you would do the bottom first and the top second. That way the hole would be a little bit more advantageous. And then you go completely around with the tape, and then you wind up with it taped down. And the tape is good tape, and it will hold. There's not a problem with that. And if it doesn't hold, they stick your hand in there and they pat it down, and it'll retape itself, or worst comes to worst, I'll have to stick some double-sided tape in the part that got exhausted. And if you want, you could throw a bead of some kind of like silicone or something around there to, like, but we're not worried about those details now because we're really just doing some prototypes. This is the creation, and this is an economical way of producing these to the point where we'll get them out there. And there's a few things that have to happen inside this toilet here, which we're going to go to next. Okay, we're going to go into the heart of the toilet, the tank. This is a tank type toilet. None of this has to be done on a toilet without a tank, but the tank type toilets do have some problems. The problems is in this device here, come in for a close-up on this, it's called a breather tube. The breather tube is its overflow tube, and it goes directly into the bowl area, and because of it, you're going to be blowing air out the breather tube. So we've invented, this is part of the patent, it's going to be a separate patent, is a valve that slides inside the breather tube and therefore won't let air out during the air burst, but will still that's why it's countersunk so much. During an overflow situation, very rare, the water will flow in here and the weight of the water will get past the valve and it will not overflow the toilet. So this goes into the breather tube. Another thing is because of the pressure from the flush, you might have the flipper be blown up because, of course, the flapper, which which covers the hole that goes into the bowl, and the pressure from the bowl will push the flapper up, and it'll throw you into a flush. And we don't want to get pushed into a flush situation, so we have. This is one of the easiest ways, or you can just put a weight on here. You could just put some kind of washers or something, or a piece of brass tubing would be great. Or better yet, you could have a piece of rubber hose. This is not rubber. It'll make it a little tricky because it's so close. And you put the little chain inside the hose, and then therefore the hose would be between the chain and your release valve, and that way you wouldn't. The release valve itself would be holding down the flapper, so the flapper couldn't get blown up. And if the flapper did get blown up, you could put some resistance on here to keep it from getting pushed up. And that would be so easy. And you could also add weights around there. And it's not that big of a situation because you have the water pressure holding it down. And another glorious thing is that if you have this device set up like this, you can still flush, by the way, with water but you'll just have to hold the handle down and let the water all run out of the tank. The nightmare to that is that's a volume of water is what they call a flush. Is amazing on these tank toilets because the air flush is going to take almost none of this. And then, like I say, by putting that in there, that'll hold it down. And even if it does get blown up, this will still push it back down immediately, and it lets a little bit of water in there is not that big of a problem, as long as it doesn't go into the complete flush where the flexible chain would do. See, the flexible chain lets it go up, and then because it has this air bubble here, it floats until all the water's out, and it's not floating anymore, then it falls back down. That's what we don't want it to do. If, with this on here, if it pushes this up, the weight is going to push it right back down again. So it'll never go into a complete flush. And like I say, a little tiny flush, it's not even a flush, it's just a little tiny letting in of water is not going to be significant as far as, over usage of water goes. So those are the two internal situations in a tank-type toilet. Now, in the other kind of toilets that don't use a tank, or even in a pressurized tank, that's a tank that has a pressurized system in here, that doesn't exist. You do nothing. Just in these type of toilets. And these type of toilets really need air flush the worst, because these are using up to 2 gallons, 2.5, 3 gallons of flush, and air flush will bring them down to maybe a quart of flush. So the savings is incredible on these kind of toilets, and it's worth the little bit of effort, which is, by the way, you know, it's not a money thing. It's just a little bit of teetering around. These not very little work. And if you really want to get started, you can just plug this up with, I've been using a plug, just a plug, which I wrapped up a plastic bag and stuck a plastic bag down there, or anything, or a cork, maybe a champagne cork, and if it's not big enough, a little extra tape around it, and just plug that thing up until you finally get a chance to put a valve in there, and you'll be fine. And as far as this goes, you could put a little bag of pennies on the chain to hang, make sure that flipper doesn't flap back up again. And they make a meterized flapper that has a hole here, so even if it goes up, it'll fall back down again. Those are required by law in California. So in California, when you flush, it doesn't go into a full flush. It only flushes when you're holding this up. When you let it go, it shuts the flush off. And that's for half flushes and full flushes, depending on the load. But we always have to be prepared for a big load. And in a big load, you just hold this down, and all the water in the tank is going to flush out that big load. And while you can also air while you're doing that, and I guess I hear rumors of some pretty big loads. So you can do this and this at the same time, and you could flush a brick down the toilet, you know. And I've heard stories of bricks. Okay. Wow.